My name is Noel Dominic Maslog and I'm gonna explain to you the central limit theorem. If a sample of size n are randomly selected from a population with mean and variance, the sampling distribution will approach a normal distribution even when the population is not normally distributed, as long as the sample size n is sufficiently large. In probability theory, the central limit theorem establishes that in many situations, for identically distributed independent samples, the standardized sample mean tends towards the standard normal distribution, even if the original variables themselves are not normally distributed. The central limit theorem states that if you have a population with mean and standard deviation and take sufficiently large random samples from the population with replacement, then the distribution of the sample means will be approximately normally distributed. We have some example here. Example, the average time it takes senior high students to finish a post-test in 45.3 minutes. The standard deviation is 5 minutes. Assume that the variable is normally distributed. B. If 35 randomly selected senior high students take the post-test, what is the probability that the mean time it will take them to finish the exam will be more than 44 minutes? So this is gonna be our given in the problem. Mean 45.3, standard deviation 5x equals 44, and sample size n equals 35. So first, we're gonna find the probability, which is px is greater than 44. And so we're gonna solve this, and this is gonna be our solution. Z equals x minus mean u over standard deviation and over square root of n, or the sample size. And we're gonna put the given numbers in the formula. So this gonna be looks like z equals 44 minus 45.3, which is the mean, over 5, which is the standard deviation, and over the sample size n, or the square root of 35. So first, we're gonna subtract the 44 and 45.3. So the result will be negative 1.3. Then the denominator 5 divided by square root of 35 to the nearest decimal places 0.84 and 8452, and dividing this negative 1.8 divided by decimal, then the result you will get will be z equals negative 1.54. And this is what gonna be looks like in the normal curve. So the graph shows this is how the student will take the post test, and then we're gonna solve the area of this part. Solution. So this gonna be our solution. Probability x is greater than 44 equals probability z greater than negative 1.54. And since we need to know the area of the students in the right side, this is what you get, 0.5 or 0.5000, and in the left side is 0.4382. Since the area of the z table negative 1.54 is 0.4382, so 0.5 plus 0.4382 is the probability of x is greater than 44, or the result will be that is 0.9382 or 93.82%. And that's all. Thank you.